Alright, so now to move on to something a little bit more complex, or something that you actually gonna have to graph and come up with. So here's another example: a motorcycle, and I'm gonna start writing stuff that way. So a motorcycle is 40 miles ahead of a car. So this is already 40 miles ahead of a car. The motorcycle travels at an average rate of 40 miles per hour. So we also know that it drives at 40 miles per hour. I'm going to say miles per hour represented by an X. The car travels at a rate of 60 miles per hour. So I know that the car is going to travel at a rate of 60 miles per hour. And again, X is going to represent hours. When will the car be ahead of the motorcycle? Cool. So I gotta come up with two expressions, and this is gonna become an inequality. So what do I know about the motorcycle? Well, I know that it's 40 miles ahead already, so that's gonna be my constant, and it's driving at an average speed of 40 miles per hour. The car, I know that it's barely starting, and it's gonna drive at a rate of 60 miles per hour. So the question is, when will the car be ahead of the motorcycle? So I want to know when the car is going to be greater than the motorcycle. Cool. So there's my inequality. Cool. Now I'm going to go ahead and graph that. So as we know, X is going to be your hours, and this is going to be your speed, or your miles. Cool. So let's go ahead and graph this. And remember, to be able to graph an inequality, or to be able to solve an inequality or an equation, you gotta kind of break that into two functions. So I'm gonna say m of x. So my motorcycle is 40 plus 40x, and my c, so c of x, so my car is going at 60 miles per hour. Cool. So I'm gonna graph the first one, which is my motorcycle. I see that I forgot something. There's an X. I see that the motorcycle is a linear function because it has a constant, which is going to be your y-intercept, and it has a slope, which is a constant slope of 40, which is it's gonna create a line. So my first point is 40, which is my y-intercept. So that's gonna be right there. And I'm going at an average speed of 40, so that's going to be 40 over 1. So rise 40, run 1. So that's going to be 40 and then up 1. Alright, so let's continue. So another 40, so that's going to be 120. Oops. And then again another 41, 40 over 1. 40 over 1, and there's my linear function. Cool. So this is m of x. Cool. I'm going to go ahead and graph the second function. So my second function is c of x, which is 60x. It's also a linear function. Now it does not have a y-intercept in terms of the function, but because it's not there, because it's not written, we assume that it's 0. So we're gonna begin with 0, and it goes at an average speed of 60 miles per hour. So my slope is gonna be 1, so that's gonna be 60 over 1, which is right there, and then another 60 over 1, which is right there. Okay. And then another 60 over 1, which is right there. And then again 60 over 1, which is right there. So there is my linear function for the motorcycle. Cool. Alright. So there's my graphical representation. Let's go ahead and answer the question. When will the car be ahead of the motorcycle? So I want to know when the red line is going to surpass the blue line. Now I see that at 2, they intersect each other. That means that at 2 hours, they are at the exact same position, right? So that means that after 2 hours, my motorcycle is going to be, or my car is going to go faster and surpass the motorcycle. So I'm going to say that my answer is when x is greater than but not equal to 2. So my car.
Good morning, Park.